Okay there, so this is a continuation of 8.1. This is 8.2, permutations with restrictions or repetitions. So let's talk about the letter book, right? B-O-O-K. Is it a different permutation if we switch the two O's? No, right? They're identical objects. So you can't count different arrangements when you switch identical items. So when we're doing that, we actually look at the formula here. And the formula is really easy. It's n factorial over r factorial. And n factorial is the number of whatever we're changing. And r is the repetition. So for instance, how many ways can the letters book be rearranged? Well, there's 4 letters, so we get 4 factorial. Repetitions, the O's, right? There's our 2 factorial. We divide it out. We find out it's 12 ways. It's really not that hard. Okay. Example 2. We have 3 identical red beads and 5 beads of varying strength. So how many in total? Well, we have 8 factorial in total. The 3 identical is the 3 factorial. We do all the math. We end up with 6,720 different variations. Okay. A child is arranging pennies and nickels in a row. Right. So we look at this. There are 4 of each, and these are fresh from the mint, so they're indistinguishable. So 8 coins in total right there, and then we have 4 pennies and 4 nickels. That's the repetition, 70 ways. So then you could also look at this. How many arrangements have pennies and nickels alternating? Well, that would be like nickel, penny, and so forth, and the other one would be penny, nickel, penny, nickel. So 2 ways for that one. Okay, so that's that first page there. Flip it to the next page. So example 4. What you have is you have 5 men and 7 women. This is now we're going to talk about restrictions. And we have 12 seats. So if you look here, I did 12 lines here because that's my 12 seats. Now, here's the deal. There's 5 men in total, and they have to sit on either end. So the first one, first man here, there's 5 ways. One of those is already gone, so the man on the other end is 4 ways. Now, how many people are left? Well, that was 12. There's 10 people left. So you could go 10 times 9 times 8 times 7, or just put in here 10 factorial. And of course, look at this number. Wow, 72 million. Like, probably an example like this, I wouldn't ask you to calculate the 72 million. You would just have to draw out the special condition. Okay, example 5. What we have here is 3 grade 10s, 4 grade 11s, and 5 grade 12s. And what we're going to do is we're filling a row of 12 seats. So what we want to do is, these are restrictions. So you could arrange the groups in other ways, right? You could say the 10s could be first, then the 11s, then the 12s, or it could be 10s and then the 12s and the 11s. So the grade groups themselves is 3 factorial. There's 6 different ways to rearrange the grade groups. Then within those grades, you have a certain 10s, 11s, and 12s, and you can then, okay, there's 3 10s, I can arrange them 3 factorial. There's 4 11s, 4 factorial, 5 12s. So then what you do is this and this and this and this. Again, because you're doing and, it's multiplication. So you find out there's like 103,680 ways to arrange all those kits. Okay, example 6. Bill walks 7 blocks to school. Right, so he can either walk east or south. So east would be going to the right, south would be going down here. So what you could do is you could do this picture-wise, right? From here to here, there's one way, then there's one way there, then there's one way to get there, one way to get there, one way to get there. Then we go south, one way to get there, one way to get there, one way to get there. Now, if you look at these other numbers, it's a 2. And what it is, it's 1 plus 1. So you go on the diagonal and add these up. Right? So 2 and 1 is 3, 3 and 1 is 4, 4 and 1 is 5. And you just keep working your way through until you get to the bottom, which is 35 different ways. Now that's a pictorial way of doing it. You can also do it with factorial. So there is 7 ways to get there, right? And there's 3 south and 4 east. So then we divide by 3 factorial and 4 factorial, and we end up still with the same answer, 35 ways. Yeah. So there's 2 ways to do that question. Okay, so let's go to the last page. We might as well do it up here. Now, these are ones with quite distinct case restrictions. So for example, how many 3-digit numbers, so we're talking about 3-digit numbers, you can see why we have the 3 lines down here, greater than 360 can be made using the digits 1, 2, 3, 4, 5, and 6 if no digit can be repeated. So what we can do is we can start with the numbers 3. So 3 has to be at the beginning. Then the next number has to be a 6. Then after that, it could be anything after that. So you can see what we've done here. Case 1, right here, case 1 starts with a 3. So there's the 3. You're not multiplying that 3. That 3 is just to tell you that it is a 3. And there's one way of getting that 3. Then it goes with a 6, and there's one way of getting the 6. And then the last number could be a 1, 2, 4, and 5, and there's 4 ways. So 1 times 1 times 1 is 4 ways. Okay. Case number 2 starts with a 4, 5, or 6. Right, because we're trying to get a number greater than 360. So the first number could be a 4, 5, or 6. Yeah, so which is 3 ways. The next number is anything except what we picked first, right? So then there's 6 numbers in total. So there's 5 now for this one, and then 4 for the next one. So 60 ways. So then what you do is we say it's this or this. So we add those cases. So we end up with 64 possible combinations, right, for this one here, right? So when you get a restriction like this, it's sometimes easier to break it into cases and then add those cases up at the end. Okay, so let's look at example 2. So a ship carries 4 signal flags of different colors. How many different signals consisting of at least 2 flags can be made? So if you look at this, there's 3 cases, right? 2 flags, 3 flags, and 4 flags, because it says at least 2 flags. Okay, so 2 flags would be 4 times 3, 12 ways. 3 flags would be 4 times 3 times 2, 24 ways. 4 flags would be 4 times 3 times 2 times 1, which is 24 ways. And then what do? You add them up, right? So in this case, the case restrictions are quite clear in what you're doing, right? You look at, break down into the 3 cases, case 1, case 2, and case 3, and then add up the totals. Okay, so that is 8.2, and look forward to the next lesson.